So with the first thing that I personally would have done for this assignment would have been to label this. You guys know I love labeling. If you had it labeled, there's very little thinking left. So which one of these is summer and how do you know? How do you know C is summer? Yes. So that is the kicker, is that you can tell that here is the North Pole and the South Pole. You can see that this Earth is leaning towards the sun. So if C is summer, what is A? Okay, directly across from summer is winter. Then you follow the arrows. Summer, blank, winter. Summer, fall, winter, winter, spring, summer. So then as you went around that, it should have been pretty easy then just to fill in the letter. So which one is March 21st? That should be B. June 21st, C. December 21st, A. December 23rd, D. Any issues with either of those? All right, Northern Hemisphere winter, A. Northern Hemisphere spring, B. Northern Hemisphere summer, C. Northern Hemisphere fall, D. Any issues up till there? Now, how about this? How do you know where in its orbit is the greatest velocity? So not answering with the letter, I'm asking a review question here. Where in its orbit does the planet go the fastest? What? When it's closest to the sun. It may have been hard to see here, so if you got this wrong, it is closest to the sun during our winter. So that would have been answer A. That is something you do need to know, that it's closest to the sun during our winter. So where are we? That would be letter A for greatest orbital velocity. Why? Because it's closest. Least orbital velocity, that's going to be when it's farthest away. That will be answer C. The sun is at its zenith at 23.5 degrees north during our summer, which is C. The equator, spring and fall, so B and D, and 23.5 degrees south during winter, which is A. The North Pole experiences 24 hours of darkness at sea. During a day at sea, so that would be our summer. And 24 hours at the South Pole of day would be A, our winter. North Pole is dark during our winter, so that's A. South Pole, 24 hours of dark is C. Now these next two, highest kinetic energy, flashback to 8th grade, which by the way, it won't be on the Regents. Highest kinetic energy is when it's moving the fastest, which is when it's the closest, which is during our winter, so that would be A. Low kinetic energy when it's moving the slowest, which is when it's farthest from the Earth or sun, which is during our summer, so C. Closest to the sun during A, farthest from the sun during C. Southern hemisphere spring is D. Southern hemisphere fall is B. Summer hemisphere winter is C. Southern hemisphere summer is A. So those four are opposite hour seasons. 9 hours of darkness in New York State, that's during our winter, so A. 12 hours of day is spring and fall, B and D. Longest day of the year is C. Winter solstice A, vernal equinox B, autumnal equinox D, summer solstice C. Any issues with any of those that I didn't already go over? Now the next one, you may have had trouble seeing this. I did leave the sub a note saying you could grab a new one if you couldn't. But again, the sun rises in the summer. Remember, the sun's like old people and goes south for the winter, north for the summer. So we've got northeast for the summer, southeast for the winter, directly east for spring and fall. How long is our sun out for the spring and fall? That's 12 hours. You don't need to memorize this 9, even though it kind of looks like it based on this question. Just know that winter is our shortest day of the year. Yes, it is about 9 hours. Summer is our longest day. That's about 15. What direction do you look to see the noontime sun? Please commit this to memory. The sun is always directly south at solar noon. Which direction do you look to see Polaris? Polaris is always north. So what happens to your shadow from sunrise to noon? It should get smaller because the sun gets higher in the sky. Then from noon to sunset, it gets longer because the sun gets lower in the sky. From sunrise to noon, the angle of insolation and the intensity, they both get higher. The sun gets higher in the sky, which makes it more intense. And then as the sun gets lower from noon to sunset, the sun gets lower, so we have less intensity. Greatest insolation, that would be summer. Least insolation, that would be winter. Don't fall for their trick. The sun never is at zenith, which means directly overhead in New York State. Sunset, just like sunrise, the sun goes south for the winter and back up north for the summer. So during winter, sun sets in the southwest. Spring and fall, it's due west, straight west. And during the summer, it's back up north, so you look northwest. Does the sun actually move? No. Then why does it look like that? It's because the earth rotates. The sun shifts 23.5 degrees each season. So why is it cold during winter? It's because we're tilted away from the sun. You could have also said low angle of insolation or short duration. Why is it hot in the summer? Because we're tilted towards the sun, which gives us a high angle of insolation and longer duration. And why does the sunset shift? That's because the earth revolves. And which on the diagram, what letter represents south? So remember that your shadow is always opposite the sun. So if the sun, and I guess this should have told you it was at noon somewhere. So on the Regents, this would have told you this was the shadow at noon. So if the shadow's over here, the sun's over here, and the sun is always south in the at noon. Questions on any of those? Okay, a couple more questions about the same idea. So what season is here? We know that this would be fall and spring, but how did you know? Because this is in New York State. So the sun's not directly overhead us or anything fancy like this. How did we know this was spring or fall? This is something you need to be able to tell me. Nobody knows? Did you all get this one wrong? Where does the sun rise and set on the first day of spring and fall? Directly east for rising, directly west for setting. So we know this is the first day of spring or fall because of where the sun is rising. What's the altitude of the noon sun according to this diagram here? It should have been around 48 degrees. What direction would you look to see your shadow? Remember, the sun is always in the southern hemisphere, so your shadow will be opposite that. Not southern hemisphere, southern sky. So if the sun is in the south, your shadow will be in the north. What's the altitude of Polaris according to this? It should be 42 degrees. Name a city. Elmira would have worked, but I believe there are other choices. So you could have also gone with Jamestown, Elmira, Binghamton, Slidemount, or Kingston. Any of those cities that are on the 42 degrees latitude. What would the altitude of the noon sun be in summer? Well, if it's 48 degrees on the first day of spring and fall, you add 23.5 degrees to that to get 75 or 71.5. What's zenith? It's directly above the observer. Does the sun ever reach zenith in New York State? No. Why? Because New York is not in the tropics. The length of the shadow from sunrise to noon, the shadow will get shorter because the sun gets higher. Noon to sunset, the shadow will get longer because the sun's lower in the sky. Longest shadow at noon will be winter because the sun's low in the sky. Greatest angle of insolation is summer, so then we have the shortest shadow in summer, and lowest angle is during winter. Any questions on those? So a lot of repetition. Hint, That means it's important. All right, moving on to moon phases. Moon number 1 would be a new moon. Then we've got waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter. Also, these are known as waxing and then waning. Either way of writing them is fine. And then we've got the waning crescent. Make sure your drawings match mine. Which ones will provide a spring tide? Remember, spring tide are when the moon and the earth and the sun are in a perfect straight line. So 1 and 5 will be the spring tide. Highest high tides, lowest low tides, biggest difference. The neap tide, which is the opposite. It's when we have the highest low tides and the lowest high tides. So the smallest difference is when the moon is directly opposite being in line. So it'll be 3 and 7. We will see a solar eclipse when we could see a solar eclipse when the moon is here at station number 1, and a lunar eclipse would only be visible here at 5. And why do we only see the same side of the moon every day? We went through that on Thursday. That's because the rotation and the revolution of the moon are the same. And what causes the phases? That's the revolution of the moon. How'd you do on those? Please don't just memorize the order. Make sure you're able to figure it out from the diagram. What is the luminosity and temperature of Betelgeuse? It is about 500,000 times brighter than our sun, and it's about 3,500 degrees Celsius. No, don't agree?
I looked at the reference table, which is in Kelvin.
Oh, yep, sorry. Kelvin, that was a typo.
I
So-
still had 3,000 Kelvin.
Well, it's not 3,000 Kelvin because there's 3,000 right there, and Betelgeuse is a little off of 3,000. So it's definitely bigger than 3,000 Kelvin.
And I had 100.
Nope, because here's 100, I guess 100. It's a little above 100. There's the 100. So I can see that and then keep in mind, here's 100, here's a million. So these don't go up in even increments. I've never seen a question that asks for the exact numbers though, just knowing that it's brighter than our sun and in the cold end of the spectrum. So same here, temperature and luminosity of Rigel, which I'm not sure if that's how you pronounce it. That one, I would say its temperature, maybe 11,000. What did they say? So they said 12,000 degrees. Again, Kelvin. I would have said closer to 11. And for brightness, if there's 1,000 and there's 10,000, we're a little less than halfway up. So about 400,000 times brighter. Again, if you didn't get that exact, it's okay. So please don't forget that the sun is a star and it does nuclear fusion. Please remember FU, sun, for nuclear fusion, not nuclear fission. Hydrogen is the fuel. So 2 hydrogen atoms get fused together during nuclear fusion to create helium. So the fuel is hydrogen. Most of the stars are on the main sequence. Our own sun is on the main sequence. Number 7, you do not need to memorize this. Our sun will turn into a red giant, however. Why can we see Orion in December, but we can't see Orion in June? That's because the Earth revolves around the sun. So if you remember during our revolution, I always used the projector as an example. During one season, I might be standing directly under the projector, but then as I revolved around my desk, the projector was no longer directly above me. So during our revolution, the constellations appear to move. What color star is Sirius? Sirius? You could have gone with white or white blue or bluish white. And what group of stars does Aldebaran belong to? I just wrote a giant, yep, so it is a giant. Okay. Any questions on those besides the ones that we already addressed? Eccentricity, our numbers might be slightly different, but I got 0.672. Again, our numbers would be different, possibly. What was I going to remind you? No units on eccentricity. So if you labeled that in centimeters, I would have had to mark it wrong on the regions. When the planet gets close to the star, what happens to velocity? It increases and it gets, the more elliptical, what happens to the eccentricity? So if it's more elliptical, it's more oval, so its eccentricity gets higher or closer to 1. And the lower the eccentricity, the more round the orbit is. How'd you do? Are you gonna ace the test tomorrow? Is there something we should focus on? All right, so I have your take-home moon quizzes for you. Once again, guys, you should have got 100 because you should have looked up every single answer that you did not know. But it is.
I don't remember it.
All the other things are needed. No, too late. It's already there. Been there since yesterday. All right, let's first start with making sure I graded it correctly. The first one, which one is a solar eclipse? So that would be when the sun gets blocked. So that would have been answer C. For all of you who skipped question 2, that's a full moon. No, nothing but the right answer is close. So remember, when you do this, you have to turn it so that you are looking straight on to the moon. When you cover up the back half, the full moon is here at location A. Guys, we definitely talked about question 3. And still most of you got it wrong. It does take 29.5 days to go from 1 full moon to 1 full moon. Those of you who picked 27.3, yes, that is how long it takes the moon to revolve around the Earth. So we did talk about this with the actual moon pops that I had. So remember, it does take the moon 27.3 days to go all the way around, which would make sense that that would be the next time you see that shape, the full moon. But what does the Earth do while the moon's revolving around it? It does rotate, but it also revolves. So the Earth is going to take a giant step forward while the moon is going around it. So it takes a little bit more time for the moon to catch up into the perfect spot to see that full moon again. So revolution is 27.3 days, but the moon cycles are 29.5. That is something you're just gonna have to remember. The highest high tides and the lowest low tide happen when the moon and the sun and the Earth are in a perfect straight line. So that would happen here at C. This is when the moon and the sun pull and tug on the tides, pulling the high tides really high and the low tides really low. August 17th would be between these two moons. So between, they call it the last quarter, but you know this is also called the waxing quarter, and the new moon. So we know it's getting smaller and the light's going to stay on the left, so that's answer D. Again, a solar eclipse is when the sun gets blocked by the moon. That's when it is in position M1, right here. If you were standing on Earth, the moon would be in the way of the sun. M3, well, that's a full moon. Again, you had to turn it so that you covered up the back half. A lot of you got this one wrong. The moon is not always the same size. And again, they said from month to month. So that's going from moon 4 back to moon 4. It's not always the same size. And that's because the moon is sometimes closer and sometimes farther away from the Earth, depending on where it is in its orbit. So its size changes because its distance changes. When the moon passes into the Earth's shadow, that is by definition a lunar eclipse, word for word from your notes. And once again, you guys did not go ahead and try this one. So when we're in A, turn it so that A is on the top of the paper. Cover up the actual back half. You will see all light in that case. That is a full moon, letter A. Why do we see these different phases? Because the moon moves around. That's called the revolution of the moon. Now, this one may have tricked you up because I didn't shade it for you, but I never shaded it for you when we practiced. So when you cut the moon in half, the side with the light is going to be on the sun side. This side would be all shaded in. So if you were standing here, again, put that moon on top, cover up the back half, you see all dark. That's a new moon, answer A. So 1, did I make any mistakes? 2, does anybody have any questions? All right, you've got a test on this stuff tomorrow. So in an effort to help you get ready, grab your packet. The last page of the packet, which is page 33 and 34, has 9 questions. Do them now. We should be able to go over them in a couple minutes. Or do you guys want to do them together? Do them by yourself or work with a friend. I'll get to the answers before the end of the period. All right, so average star. What's that place where we put average stars? What's the name of it? Main sequence, so that's letter B. The Earth's year is based on the revolution, not the rotation. They tried to trick you here with the 15 degrees per hour or the 1 degree per day. Remember that the Earth spins. So for rotation, we spin 360 degrees in 24 hours. That equals 15 degrees per hour. This is rotation. Revolution, we go around the sun, which is about 360 degrees, in about 365 days. That gives you the 1 degree per day. So please don't fall for their tricks. And yes, you do need to know the degrees per hour. A Milky Way, that's a spiral-shaped galaxy composed of billions of stars. So they tell you here, Mercury moves more rapidly. Mercury is the first planet in the solar system, so Mercury is closest to the sun. Pluto was the farthest away before it was demoted, so Mercury moves faster because it's closer. What's represented by X? Now they do, oh, I lied. Ooh, they told you in the reading, this is a geocentric model. So if it's geocentric, that's the Earth. That was me not reading the question. So please read the question carefully. How do you figure out the size for this scale? Where do you just guess? Reference table, you should have seen that. Venus and Earth's diameter. Sorry, I got a shiny reference table here. They're almost, there we go. Turn the light off. I'm sorry, but they're almost exactly the same. They're 12,104, 12,756. So first of all, which one is definitely wrong? Okay, you're right. All of those are wrong. 1, 2, and 3 are definitely wrong. 1 is wrong because Earth is smaller. 2 and 3 are smaller because Venus is not that much smaller. It's barely noticeable, the difference. It's only 600 kilometers. That is not very far. Which one has the lowest density? Again, check your reference table. You know me, I like to label. So Mars definitely has the lower. The actual orbits of the planets are elliptical with the sun at one foci. And number 9 is a think about it question, but I've never seen it on the Regents. It is because they revolve around the sun on the inside of Earth's orbit. Tomorrow, like I said, is a test on everything in this packet. You've had quizzes, you've had homework, you've had review worksheets. You should know everything on them for the test tomorrow. Your final Earth Science test, besides the Regents.